With sets, many times we will visually represent a set, and we do that with what's called a Venn diagram. And in a Venn diagram, we'll have a rectangle that represents the universe, and the sets are represented by circles or sometimes ovals inside of that universe. So in this diagram here, we're going to be talking about a complement of set A. So set A is represented by this blue oval inside the universe, and the complement of a set is everything not in the set. So in this case, the complement of the set A is this pink area, okay? We represent the complement with the set letter name with a small horizontal bar over it. So this is read the complement of set A. So it's everything that's not in A. So if you're talking natural numbers and A is the set of even numbers, the complement would be the odd numbers. So everything not in set A. This next definition is a subset, and we'll actually get a little more refined with this definition in a second. But a subset is a set that is contained within another set. You can think of subset the way we would use a less than or equal to. So the subset A, the set A is a subset of B if every element in A is also in B. Now, let me just keep it real simple here. If A contained the numbers 1, 2, 3, and so did B, A would still be considered a subset of B. It's that idea of less than or equal to. That's a subset. Now, in this case, A and B are equal to each other, so we could write A equals B. But then we can also talk about a proper subset. And with numbers, you can think of a proper subset the same way you would think of a strictly less than. To be a proper subset, A has to be smaller than B, okay? So for two sets, or for one set to be a proper subset of another, it has to have fewer elements. So in this case, A and B are equal, so A is not a proper subset of B, but if I were to erase one of the numbers in A is now a proper subset of B. Okay. It's a subset, but it's smaller. That's called a proper subset. And again, think of less than versus less than or equal to with those. The bottom of the page, I have the definition of an empty set, but we talked about this already. Empty set has nothing in it. If you're familiar with Greek letters, this is similar to the Greek letter phi, but the Greek letter phi, just in case anybody's curious, the bar is more vertical, where here it's more to diagonal, just in case you're interested. So let's continue with these definitions. We can talk about the intersection of two sets, and that is where they overlap. We use this symbol that looks like an upside down U to represent intersection. You might think of it as a stylized N for intersection. If set A contained the numbers 1, 2, 3, and B contained the numbers 2, 4, 6, the intersection would be the number 2. That's what they have in common. That's our intersection. In a Venn diagram, it's where they overlap. Now, sometimes two sets do not overlap, and they are called disjoint. So if you had set C, which was the numbers 1, 2, and 3, D was the numbers 4, 5, and 6, they're disjoint because they have no overlap. In the bottom of the page, we're going to talk about the union of two sets. The intersection is much more exclusive. With the intersection, it is just the overlap. The union of two sets, everybody's part of the mix. So when we talk about the union of sets A and B, it's everything in set A plus everything in set B. So if A was equal to 1, 2, 3, and B was 2, 4, 6, the union of A and B would be everything in A and everything in B. The 2 is repeated in both sets, but I only need to write it once. So the union would be the numbers 1, 2, 3, 4, and 6. Everything in A, everything in B. Again, nothing is excluded here. So we're going to look at a couple examples here and decide whether these are true or false. A says, the set containing the number 7 is a proper subset of the set containing 6, 7, 23. And that is true. So a proper subset, that's the idea of a less than, if you're just dealing with numbers here. So 7 is contained in the set 6, 7, 23, and the set containing just a 7 is smaller. Part B, the set containing 6, 7, 23 is a proper subset of the set containing 7, 23, 6. This one, even though the sets have the same 3 numbers, it's going to be false, and it's because the 2 sets are equal. To be a proper subset, that first set has to be, I'm putting this in quotes, smaller than the second one. So you could say the set containing 6, 7, 23 is a subset of the set containing 7, 23, 6. It's just not a proper subset. And then the last one, the set containing the number 6 is a subset of the set containing 7, and that one is false as well, because 6 would need to be contained in the set on the right, and it is not. I'm going to do one more video for this section. We're going to look at a couple more examples with sets and working with those. I hope this is useful for you.